Good morning, class, and welcome to this lesson on Geometric Optics 1, Reflection and Plane Mirrors. Today, we will be able to describe the law of reflection and the type of image that forms with a plane mirror. Okay, so we're going to describe a law here, we're going to talk about what plane mirrors are, and a whole lot here. So let's just get started. The first thing we want to do is we need to discuss light rays. We need to discuss light rays, okay, or just rays for short. Okay, and as you can see from this picture here, this is a source of light, and it's going to send light rays in all directions. So notice these light rays are moving in all directions away from the source. And notice that we draw light rays as just arrows. As arrows emanating or originating from the source. Okay? And we draw these as straight lines. Okay? This may sound kind of basic, but I'm going over for a reason, because we're going to draw a lot of light rays, and they're just straight lines coming from the source, okay? So, and we just draw them as arrows. So, the law of reflection. The law of reflection basically says that the angle of incidence equals the angle of reflection. Or in other words, the angle of incidence equals the angle of reflection. And what does that mean? The incident ray is the incoming ray, the incoming light ray. Notice straight line arrow. And the angle of and the reflected ray is the outgoing ray. And with any mirror, the angle of incidence is going to equal the angle of reflection away from the normal. Away from the normal. The normal is this line right here. The normal is the perpendicular line to the surface. The perpendicular line to the surface. So we have a plane mirror. It is a flat mirror. It is on a plane. It has a normal. This is the perpendicular line away from the sphere. And so if we have an incident ray coming in, a light ray coming in, let's say this angle is, I don't know, 30 degrees, the angle of reflection is going to be 30 degrees away from the normal as well. Okay? So that's the law of reflection. There's no real equations there. It's just a law. It's just that right there. The angle of incidence equals the angle of reflection. So that's going to be a major theme coming up throughout the rest of all these physical optics videos. Okay, the angle of incidence equals the angle of reflection. Okay, so let's look at a plane mirror. Okay, a plane mirror meaning a flat mirror. Okay, you can see here we have a flat mirror. Okay, when you look into a plane mirror, you see an object that has three properties. Okay, so we have three properties here. Number one, the first property is the image is upright. The image is upright. So notice in this example right here, we have a rook from a chess piece. The image that we see in the mirror is upright. Okay, when you look into a mirror yourself, you're not upside down, you're upright. The image is the same size as you are. The image is the same size. So notice if this was, I don't know, 5 centimeters, then this would be 5 centimeters. And the image is located as far back as the object. Okay, so this was, I don't know, we'll say 10 centimeters away, then this would be 10 centimeters away, just to give a random number there, okay? Now, these are all things that you probably know but never thought of because you looked into a mirror many times. We all have. But this just sets the tone that we're going to be talking about if an image is upright or not. We're going to be talking about if an image is the same size or not, and we're going to be talking about where the image is located in relation to a mirror. Now, for a plane mirror, it's pretty simple, okay? Everything's pretty much equal. Image is upright, like you, same size as far back. So these equal things are very easy to understand. But when we get into curved mirrors, then it's going to change a little bit. However, there are some things I'm going to define here, and I'm going to start off with this picture right here. This, as you can see in my picture, down here, this rook on this side, this is called a virtual image. Okay, a virtual image, because no light rays, I'll write this down, virtual image. No light rays emanate from the image. Okay, what does that mean? This image is not producing light. This is not producing light. What it is this object, a rook, is casting off light. Everything that you can see is casting off light, okay? It's casting off light. It's hitting the mirror at a certain angle. Excuse me, wrong angle there, wrong angle. It's hitting the mirror at some, here's the normal. It's hitting the mirror at some angle right here. It's reflecting at the same angle. And so these are the reflected rays, okay? These are the reflected rays right here, okay? That's what we see. And so what we're going to do a lot is that we are going to draw dashed lines from the reflected rays, not the incident rays, not the incident ray. And we're going to draw them back, okay? And you can see we draw them using dashed lines here. And these two dashed lines connect right here, which with a plane mirror, as you can see, is just as far back as the image that was casting off the light, okay? So there's something I want to show you there. Virtual image, no light rays emanate from the image. This is in contrast to a real image. And it's easier for me to show you in the next couple of videos than to describe this right now. So we're going to get into what a real image is in the next couple of videos, okay? So this is coming up soon. It's coming soon to a theater near you. So but what I want to show you is that the image you see in a mirror is called a virtual image, not a real image, because there is no light coming from here. The light is coming from here. We just see it as coming from back here. This is an extension. This is the extension. This is the extension of the reflected rays. So we're going to end with this interesting concept here. If you want to see your whole body, do you need a full-length mirror or a half mirror? So looking at this picture right here of this woman, she wants to see her whole body. She wants to see head to toe, okay? Checking herself out here. So she wants to see her whole body. That means she wants to go as far as her feet. Well, if her feet are casting off light in all directions, she's sending off light rays in all directions, what happens when a light ray hits right, we'll say, here? Okay, well, we know the angle of incidence is going to equal the angle of reflection. And so this light ray that is below the halfway point, this is the halfway point, is not going to hit her eyes, okay? According to my drawing here, this light ray is going to hit her waist about, okay? So basically what that means is any light rays that hit below the midpoint from where your eyes are, you're not going to see anyway, okay? You're not going to see them anyway. So the reality is, to answer this question, to answer this question right here, you can see your whole body with a half of a mirror. With a half mirror. You don't need anything in this section right here, because the light rays coming from your feet need to hit the mirror. The angle of incidence is going to equal the angle of reflection, and so what you're going to see from right here is going to appear to come from down here, despite the fact that it's actually coming from over here. This is a virtual image. And notice we did the same thing here. This is the reflected ray, and we drew an extension of the reflected ray back on this woman right here to show you what you see from your eyes. Even though the light's coming from your feet here, it looks like it's coming from here. Virtual image. No light is coming from here, it's actually coming from here. Okay, so that's an interesting question to think about. You don't need a full mirror to see yourself. You need a half a mirror, because anything that hits below the half, you're not going to see anyway.